In the 1880s, the police knew next to nothing about ballistics evidence, where a bullet was fired from, or matching it to the gun. But Sherlock was already ahead of the game. It was almost 40 years before the FBI took Sherlock's work further, matching bullets to guns after the notorious St. Valentine's Day massacre. But in Sherlock's time, with ballistics in its infancy, the great detective was way ahead. In Sherlock's case of the Reigate Squires, a man has been shot and killed, allegedly at close quarters, during a struggle. But Sherlock's observation of the body immediately leads him to a different explanation.
The wound upon the dead man was, as I was able to determine with absolute confidence, fired from a revolver at the distance of something over 4 yards.
What Sherlock's able to do is determine that their claim that they were fighting at close quarters is invalid.
I could see no trace of powder blackening on the clothes.
He does that by observation of gunpowder soot deposit, or rather the lack of it. Guns discharge, particularly black powder firearms, discharge an awful lot of soot. What most people know as powder burns. In fact, there is burning at very close range. Beyond that, there's a projection of this black, sooty deposit. That discharge becomes undetectable, certainly to the human eye. And from that, he confidently pronounces, using his observational and deductive abilities, that the firearm must have been discharged from over 4 yards away, and this was a straightforward shooting.
Evidently, therefore, Alec Cunningham had lied when he said that the two men were struggling when the shot was fired.
Sherlock anticipates the abilities that modern forensic science has, that we can actually now convict criminals on the basis of scientific evidence. And Sherlock was there at the beginning, doing that in fiction. But he was also quite eerily prescient about this, because the very same year that the case of the Reigate Squire was published, the Ardlamont mystery took place on an estate in Argyllshire in Scotland.
In August 1893, tutor Alfred John Monson took Cecil Hamborough, his 20-year-old pupil, hunting on the Ardlamont estate in Argyll, Scotland. Estate workers heard a shot, then saw Monson running to the house. He said his young pupil had accidentally been shot, dead.
The boy was found dead. He had been trying to climb over a fence. The gun became hung up on something and discharged, and it killed him. Sounds very Holmesian already, but who should be drafted in to help Crown's evidence but Dr. Joseph Bell?
Dr. Bell was Scotland's most eminent surgeon and the living inspiration for Sherlock Holmes. The great detective shared Bell's powers of deduction. Bell resolved to carry out test firing to see at what distance he could recreate the allegedly close-range wound.
Bell was satisfied that it was impossible for a shot to have been fired at anything less than 4 feet away, so something else was clearly going on.
But Bell's experiments had proved a further critical point in the case, hinging on the different size of shotgun the two men had each been carrying.
The fatal shot had been fired by a large shotgun, something rather like this, something of 12 bore. Now, the victim was not armed with a shotgun of this bore. In fact, his tutor was. The obvious implication was that, in fact, he'd been murdered.
Joseph Bell, the model for Sherlock, had now himself followed in the great detective's footsteps and further established the credibility of ballistics evidence. Sherlock was the first to showcase other important aspects of ballistics science, not least the groundbreaking area of bullet trajectory, in a case that involved a murder-suicide shooting.
But there were still 4 cartridges in the revolver. 2 had been fired and 2 wounds inflicted so that each bullet could be accounted for.
So it would seem. Perhaps you can account also for the bullet that has so obviously struck the edge of the window.
By George. However did you see that?
Because I looked for it.
Now, not only does Holmes spot this bullet hole, by examination of this hole, he's able to determine which direction the bullet has passed. With a gunshot, the exit is larger than the entrance. The entrance of that little tunnel created by the bullet will be about caliber size, about the size of the bullet. And the exit will be larger. It will splinter. It will create spalls of wood.
And a 3rd shot's been fired, and therefore a 3rd person has been present. But who could that have been? And how could he have got away?
That is the problem which we are now about to solve.
Like a good forensic scientist, Holmes immediately seeks to confirm his hypothesis and look for a piece of evidence that, of course, he already knows is there.
The servants say they found the window open. There might have been a 3rd person in the affair who stood outside the opening and fired through it. I'll see what fresh evidence out here has to offer.
And he finds, virtually right away, the ejected case from the weapon that belonged to this 3rd party.
I really think, Inspector Lestrade, that our case is almost complete.
This sort of advanced thinking about where bullets are coming from, where they're going, and what they're passing through in between, it comes before an awful lot of real-world crime scenes that would exist later, where trajectory was vitally important. Holmes is really ahead of the game in terms of the forensic reality.
Next time on How Sherlock Changed the World.
Sherlock Holmes is a person that we all